Here in front of me, I've gone ahead and assembled the pieces that we're going to need to build a model of 3-bromo, 3-ethylpentane. Looking at the name itself, pent tells us that we're going to need 5 carbons in our parent chain. Ane tells us that we will be building an alkane, which we know consists of only single bonds. So I've gone ahead and constructed that parent chain here. I've also got a bromine and an ethyl group here. Ethyl groups are second nature to us at this point in the semester, but just to recap, looking back at an earlier lesson, the ethyl group is ethane with the hydrogen substituted out, and it goes on to become a substituent group. I'm going to pause my building progress momentarily to give you all a chance to catch up. As you're able, please go ahead and construct the small pieces that I have here. While you're doing that, I just want to briefly touch on what I feel to be the importance of the molecule kits. You might look at this and think 3-bromo, 3-ethylpentane is a pretty straightforward molecule. And with that considered, it might seem like a bit of overkill that I'm asking you to build a model when the question itself is asking us to go ahead and draw the structure. But because it is a pretty straightforward molecule, I think that's what makes this the perfect opportunity to get a little bit of hands-on. So we're going to build this. It's going to take just a minute, but we'll be able to look at it as a visual later. We can reflect back, kind of compare our drawing to what we've got going on here. So not only is it going to help us get some practice, but it'll be a good reference tool. The more comfortable you get building these molecules, the more successful you're going to be as a whole. Building models is a tool for success in organic chemistry. The more you practice with the smaller molecules, the better you'll feel when the questions come up where you need to build a model for the more complicated molecules that really need to be visualized. So I really do believe in practicing models whenever you have a spare minute. Now that you've probably all got a chance to catch up, I want to go ahead and move forward. If you look at the name again, 3-bromo, 3-ethylpentane, our prefixes tell us what our substituents are. So we got bromo for bromine, and we have ethyl for our ethyl group. Our locants, which in this case are both 3, tell us that our substituents are both located off of carbon number 3 of our parent chain. Because this is a 5-carbon parent chain, 3 is in the direct middle. We're going to end up off of this carbon whether you number your carbons from left to right or right to left. We'll talk a little bit more about the attached hydrogens momentarily when we discuss drawing condensed structure, but for simplicity's sake, I left them out here because it's understood that carbon makes 4 bonds. And so based off of what we see here and how many bonds exist at all of these carbons already, we know what we need to fill in. I'm going to go ahead and complete this. So if we go ahead and we attach our substituent groups, I'm going to leave this guy turned on his side because you'll see the substituents better, but just so that you can see as a whole, we've got our 5-carbon parent chain, our bromine and our ethyl group both off of carbon number 3. For later on, I've completed another model and it does have the hydrogens attached. I don't expect that you guys will go ahead and attach all these. If you want to, please by all means go ahead and pause the video. But I just wanted to show you that I've gone ahead and made that. I'm going to use that as a visual later to double check my work, but you can certainly do the same if you would like. For now, your models can be set aside and we're going to move on to drawing our line structure.